Hello student, today we are going to see the next concept of this chapter, that is the electrostatics, that is the capacitor and capacitance, and then combination of capacitors in series and parallel. Now let us see how these combinations are derived. Okay, see the conductors 1 and 2 as shown in this diagram. Suppose this is the conductor 1 and this is the conductor, that is the second. Then they having the charges, that means the charges associated with this conductor number 1, that is the positive Q, and second one is having the charges minus Q with potential difference V. Here this having the potential difference V1 and this having the potential difference, that is the V2. And so the total difference between them, that is the V, is equal to V1 minus V2 between them. The electric field in the region between them, that means between this conductor 1 and this conductor 2, the electric field in the region between them is proportional to the charge, that is the Q, and then the potential difference V, that is the work done to carry a unit positive test charge from conductor 2 to conductor 1 against the field. And so that this work done will proportional to this charge Q. And this work done is nothing but the potential difference. So we can say this V directly proportional to this Q. And this Q upon V is a constant. Now here we are going to see how this concept, that is the capacitance, arises when we put these two conductors 1 and 2 near about or in vicinity each other. Then what happens? See this proportionality constant, that is Q charge, and this potential V, potential difference V, is constant, and that constant is called as the capacitance of the capacitor. This ratio, that is the Q upon V, is a constant, and that constant is called as the capacitance of the capacitor, which depends on the size, shape and separation of the system of two conductors. That means this capacitance is depends upon what is the size of these capacitors and shape of this capacitor and the separation, that means the distance between these two conductors of the system. And on that factors, the value of this capacitance is depends, and this capacitance is nothing but what? The ratio of charge per potential difference. See the SI unit of this capacitance. The SI unit of this capacitance is farad. And this 1 farad, as per the definition Q upon V, 1 farad is equal to 1 coulomb upon 1 volt. And as per the dimension, with the help of this formula, we can obtain the dimension, that is m raised to minus 1, s raised to minus 2, p raised to 4, and this a raised to square. In this way, we see the new concept here, that is this capacitance. Capacitance is nothing but the ratio of the charge per potential difference, and that ratio is constant, and that constant is called as the capacitance of the capacitor. In this way, we have learned this concept, what is the capacitor. Now see, what is the principle of capacitor? What is meant by capacitor? Capacitor is nothing but when one conductor and second conductor are placed with each other, having some distance between them, and such a type of arrangement is called as the capacitor. Let us consider a metal plate P1 and having the area A. First of all, see, this is the metal plate P1 having the charge positive Q here, which is shown in diagram also. Then let us, this charge, that is the positive Q, given to this plate, and hence the potential becomes V. Its capacity is given for this plate P1. First of all, we are finding the for this plate P1 the capacitance as per the definition Q divided by P. Therefore, the charge positive Q, here you can also write that this positive Q, here I have written only Q, that means nothing, that is the positive Q. Okay, then C1 is equal to Q divided by P. Now consider another insulated metal plate P2 held near the plate P1. म्हणजे या प्लेट P1 च्या कॉन्टॅक्ट मध्ये आपण एक दुसरी मेटल प्लेट घेतलेली आहे P2. ओके, आता ह्या पॉझिटिव्ह चार्जमुळे ह्या P2 च्या जे इनर साइड आहे त्याच्यावरती काय होणार आहे, निगेटिव्ह चार्ज इंड्यूस होणार आहे. बिकॉज ऑफ दिस पॉझिटिव्ह चार्ज induced negative charge on this plate P2 on the inner side of this P2. So now consider another insulated metal plate P2 held near the plate P1. By induction, a negative charge is produced on the nearer face and equal positive charge develop on the farther face of the P2. On the another side, again because of this negative charges, on the another side of this plate P2, there is the induced positive charge. What is meant by induced? Induced means च्यामुळे, because of this positive charge, there is a negative charge on the plate P2 on the outer side of the or in front side of this P1, and because of this negative charges, there is the formation of positive charges on another side of this P2. Then this if V1 is the potential on plate P2, म्हणजे V1 जसं आपण V हे पोटेन्शियल घेतलं P1 साठी, तसंच आता P2 साठी आपण V1 हे पोटेन्शियल कन्सिडर करतोय. ओके, इफ V1 is the potential on plate P2 due to charge minus Q, then what is the net potential of the system because of this both conductor, or we can say because of the both plate, therefore this positive and this minus V1. Okay, addition of this both, that is the first one having the potential V and second one having the potential minus V1. So the total system potential if you find, then this value is, that is the positive V minus V1. Hence the capacity C2 is equal to, capacity of CT is equal to, that is the Q divided by V minus V1. Because of this V, there is the induced, that is the V1 is the potential on plate P2 due to charge minus Q1, and so you are finding here the capacitance of the second capacitor, or you can say second plate P2, therefore which is V1 by Q, therefore the potential difference, that is the V minus V1, and therefore C2 is greater than C1. Why? Because this V is the potential of this C1. So because of this, here this formula, if you observe this formula carefully, then you can say the capacitance of the capacitor C2 is greater than C1, and thus the capacity of metal plate P1 is increased by placing an identical or connected metal plate P2. म्हणजेच तुम्हाला जर एखाद्या कॅपॅसिटरची कॅपॅसिटी वाढवायची असेल तर कशी वाढवणार, इज इन्क्रीज बाय प्लेसिंग अँड आयडेंटिकल, त्याच्याच सारखी दुसरी मेटल प्लेट काय करायची, त्याच्या सानिध्यामध्ये ठेवायची, की त्यामुळे काय होणार आहे, बिकॉज ऑफ दिस पॉझिटिव्ह चार्ज negative charge induced on it, and because of this induced charge, negative induced charge, there is the formation of positive charge. And if this all positive charge, see in this next second diagram, all this positive charge, if you due to the earth, that is the earthing, you can say it, thus the capacity of metal plate P1 is increased by placing an identical or connected metal plate P2 near it. Such an arrangement is called as the capacitor. आणि ही जी काही आपण अरेंजमेंट केलेली आहे याला आपण काय म्हणणार आहोत, कॅपॅसिटर. and it is symbolically it is given by this sign. Okay, this is nothing but the plate P1 and plate P2, and this symbol is given to indicate that is the capacitor. In this way we see here what is the principle of the capacitor. To understand this principle of capacitor, here we see the plate P1 and plate P2. First we find out the potential between this P1, and then for the both system, that is the P1 and P2, and with the help of this we can see how we increase the capacity of metal plate P1 using the identical another metal plate P2 near it, and such a type of arrangement is called as the capacitor. Now see the combination of capacitors. We combine these capacitors in a two ways. First one is series and second one is parallel. a capacitor in series. See, when these capacitors in series, that means when a potential difference V is applied across several capacitors connected end to end in a such a way that sum of potential differences across all the capacitors is equal to applied potential difference. See in this diagram, this V1, this V2 and V3. That means V is equal to V1 plus V2 plus V3. This is basic when you attach or arrange the capacitor in series. What is the meaning of that? That means the V is equal to V1 plus V2 plus V3. That means the several capacitors connected end to end. See, this is first capacitor. Now this total system is now called as the capacitor. We learn. Okay, this total system is called as the capacitor. This is the capacitor 1, this is capacitor 2, and this is capacitor number 3. So this capacitor 1 is connected to second, and this second is connected to third, and this first, second and third are connected in series. सेरीज म्हणजे एका पुढे एक जे जोडलेले आहे त्याला आपण काय म्हणतो, सेरीज अरेंजमेंट. म्हणजे ह्या पहिल्याचं जे काही एंड आहे हे दुसऱ्याच्या फर्स्टला दिले, दुसऱ्याचे जे काही एंड पॉइंट आहे हे तिसऱ्याच्या फर्स्टला दिलेलं आहे. अशा पद्धतीची जे काही आपण अरेंजमेंट इथे केलेली आहे त्याला आपण काय म्हणतो, series arrangement. And therefore here the most important word here, sum of potential difference across all the capacitors is equal to the applied potential difference. Here we applied the potential V, and that applied potential V is nothing but the equal to sum of all the potential difference of this capacitor. For first capacitor this is V1, and for second V2, and for this third one V3, and therefore as per this series combination, this V is equal to V1 plus V2 plus V3. In series arrangement, the second plate first, that is the second plate of first conductor is connected to the first of the second conductor, and so on. As already I told this is what the second plate of the first conductor, which is given to the first of the, see, this is the first of the second conductor. Similarly, again, this is the second, and which is given to the first of the third one. In this way, we can join these capacitors, or you can say conductors, in series. The last plate is connected to the earth. See, this last, all these positive charges given to the earth. Charges on these plates, positive Q and minus Q, are the same on each capacitor. Potential difference across the series combination of capacitor is V, and see the charges, that is the positive Q minus Q. In this way, we arrange these capacitors or conductors in series. Now, we are going to find out what is the formula for the total capacitance in series combination. That is we are going to find out the formula for CS. See, this V is equal to V1 plus V2 plus V3. So make the equation for this V1. For this V1, that means for first capacitor. Therefore, for first capacitor, charge is same. Therefore, Q divided by C1 for first capacitor. Similarly, V2 for the second capacitor, Q divided by C2 plus for third capacitor, Q divided by C3. And let us see us. What is CS? That is the equivalent capacitor in series combination. What this S represent? S represent series combination. This represents the equivalent capacitance in series combination. As per the definition, we hear this with the help of this formula. We write down this V is equal to, what is the formula? This V1, that is the Q divided by C1, plus V2, that is the Q divided by C2, plus what is this V3, that is the Q divided by C3. Therefore, Q is equal to, this V is equal to what? This V is equal to charge, and that is the series combination, that is the equivalent capacitance. Therefore, Q divided by CS, which is equal to, again, this Q C1 plus Q C2 plus Q divided by C3. Therefore, 1 upon this, therefore 1 upon CS, which is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. In this way, this QQ constant, this argument, this can be extended to an equivalent capacitor, that is for n number of capacitor. Here, for our convenience, we have taken only 3 capacitors. Okay, but if we want to make the equation for n number of capacitors, then simply here for the 3 capacitors, we can make the equation for n number of capacitors, that is the 1 divided by C equivalent capacitance is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3 plus dash dash up to 1 upon Cn. If the capacitors are equal, then that means equal, then 1 upon this C equivalent is equal to n divided by C, or you can say that this equal, that is the, if all capacitors are equal, that means n numbers, then n divided by C. Therefore, this C equivalent capacitance is equal to C divided by n. In short, this circuit we can represent also, instead of this V, and instead of this all capacitance here, we write here CS. Instead of this 3, 1, 2, 3, we got CS, and therefore the short form of this circuit here CS and V. CS, that is the equivalent capacitance in series combination. In this way, we see the how we obtain the series combination CS. And remember here one thing, that is the series combination is used when a high voltage is to be divided on a several capacitors, and capacitors with minimum capacitance has the maximum potential difference between the plates. In this way, we see the formula for this C. Yes, that is the equivalent capacitance. Now let us see how we join these capacitors in parallel. Now see the parallel combination. The insulated plates, this that means this parallel arrangement of capacitors as shown in this diagram. See, this is plate 1, plate 2, or plate 3. Also you can say this capacitor 1, capacitor 2, or capacitor, that is the 3 number. The parallel arrangement of capacitors is as shown in this diagram, where the insulated plates are connected to a common terminal. See, all these are connected, these 3 are connected to this common terminal A, which is joined to the source of potential. Here this A is joined to the force, that is this terminal. Okay, while the another plates are connected to another common point, that is there, this B, and this B is connected to the another common point, that is the of this positive terminals here, all the positive terminals given to the earth. Okay, in this way we join this parallel combination. See once again, in this combination all the capacitors have same potential difference. See, in first case here the V1 plus V2 plus V3. Now in this case, each and every capacitance having the same potential difference, but the plate charges, that means Q on the capacitors, these are the difference. Okay, therefore Q is applied at the point A, and then it will be distributed to the capacitors. From this point, this Q is distributed like this, from this A point for the capacitor C1, Q1, this Q2, and this one is Q3. In this way, here the charges is distributed in case of parallel combination, and in series combination potential difference is distributed. Now see, the total charge Q can be written as, therefore this Q is equal to Q1 plus Q2 plus Q3. With the help of our definitions, again this Q is equal to C1 V1 plus C2 V plus C3 V. Therefore, the CP, that is the parallel equivalent capacitance for the parallel combination, and for the equivalent, that means for Q, which is equal to CPV. Therefore, instead of this Q, we can write down this CPV, that is the total charges in parallel combination total voltage. Therefore the formula, that is the, we know that the basic equation for the capacitance, that is the Q divided by V, which is equal to C. Rearranging the equation for the Q, therefore CPV is equal to C1V plus C2V plus C3V. Therefore this V here common, V common, V common, therefore this VV gets cancelled on left right side. Therefore CP is equal to C1 plus C2 plus C3. The general formula for effective capacitance Cp for parallel combination of n capacitors is like this. That is the Cp is equal to, here we see the formula for only 3 capacitors. And if you want to make the formula for n number of capacitors in circuits, then we can make the formula, or you can generalize this formula. Cp is equal to C1 plus C2 plus dash dash up to plus Cn. In this way, we see the how we obtain the parallel combination, that is the Cp value. If all capacitors are equal, then you can write down Nc, that is the C capacitance in parallel, which is equal to Nc. Once again, remember one thing, capacitors are combined in parallel when we require large capacitance at a small potential. If you want large capacitance at a small potential, then you have to arrange the capacitors in parallel combination. In this way, we see how we join this parallel and series combination, and respective formula for series and parallel combination of capacitors. Now see the next concept of this chapter, that is the capacitance of a parallel plate capacitor without and with dielectric medium between the plates. What is this dielectric? That is the non-conducting materials. Dielectric is nothing but the non-conducting material. If we put or fill the space between the two plates with the dielectric material, then what happens? म्हणजे जर ते दोन प्लेट जे आहेत कॅपॅसिटरचे, प्लेट P1 आणि प्लेट P2 यांच्यामध्ये जो काही गॅप आहे, त्याच्यामध्ये जर आपण डायइलेक्ट्रिक मटेरियल फिल केलं तर त्याचा याच्यावरती काय परिणाम होईल? ओके, द कॅपॅसिटन्स ऑफ पॅरलल प्लेट कॅपॅसिटर विदाउट अ डायइलेक्ट्रिक. First upon, we are going to see without dielectric and then with dielectric. A parallel plate capacitor consists of thin conducting plates having the area A held parallel to each other at a suitable distance D apart. म्हणजे इथे आपण दोन प्लेट्स घेतलेले आहेत की ज्यांचा एरिया A इतका आहे, त्या दोन प्लेट्स मध्ये डिस्टन्स D इतकं आहे. ओके, when a charge positive Q is given insulated plate, then a charge minus Q is induced on inner face of earth plate, and positive Q is induced its further face, but as this is earth, the positive Q being free flow to the earth. Once again see, या प्लेट वरती पॉझिटिव्ह चार्ज आहे, या पॉझिटिव्ह चार्ज मुळे दुसऱ्या प्लेट वरती इथे निगेटिव्ह चार्ज तयार झाला. या निगेटिव्ह चार्ज मुळे त्याची जी बाहेरील जी साइड आहे त्याच्यावरती परत पॉझिटिव्ह चार्ज तयार झाला, आणि तो पॉझिटिव्ह चार्ज आपण काय केला? अर्थिंगला दिलेला आहे. ओके, so now focus between this positive charge and negative charge which is on the inner side of this plate P1 and P2. But at this here in the outer region, the electric fields due to the two charges plates cancel out. That means on the outer side this E bar and this E bar, that means gets cancelled, and therefore we are focusing on what happened on in the inner. That means between these plates P1 and P2. Okay. Therefore, the net field is 0. That means E is equal to, we know that the basic of this chapter, when we learn the applications of the Gauss theorem, we know this E is equal to, for this type of structure, that is the sigma divided by 2 epsilon naught minus, again for the second plate. Therefore, in the inner region, the net field is, this is the outer, that is the get 0, and the inner it gets plus. Okay, therefore E is equal to sigma divided by 2 epsilon naught plus sigma for the second plate 2 epsilon naught, therefore which is equal to 2 sigma divided by 2 epsilon naught, therefore 2 get cancelled, and finally we got the equation sigma divided by epsilon naught. Again, what is this sigma? This is nothing but the charge per unit area. Therefore, putting the value of this sigma here, we got the equation E is equal to Q divided by A epsilon naught. And the electric field between the plate is given by, that is the direction of E is from positive to negative plate. So let V be the potential difference between the plate 2. Therefore, the electric field between the plates is given by, we know this formula, that is E is equal to V divided by D, or make the equation for V is equal to E into D. Therefore, V is equal to, what is the value of E? E is equal to Q upon A epsilon naught. So putting the value of this E, that is the Q divided A upon epsilon into D. Capacitance of the parallel plate capacitor is given by, here we obtain the equation of this V. Therefore, C is equal to capacitance, equation काय आहे? Q divided by V, that is the ratio of charge and potential difference. Therefore, Q as it is. And then what is the equation with the help of these two plates without dielectric? This Q is equal to, this V is equal to Q divided by A epsilon naught into D. Therefore, this Q get cancelled, and this A epsilon naught get on the another side, that is at the upper position. Therefore, this C is equal to A epsilon naught divided by D. In this way, we obtain here the equation for the capacitance of the parallel plate capacitor without dielectric. Now we are going to obtain the capacitance of a parallel plate capacitor with dielectric slab. Now we are putting non-conducting material between this, and then we are going to see what is the capacitance. Consider a parallel plate capacitor with two plates, each of area again A, separated by distance D, but here with a dielectric slab. Here this dielectric slab is given here between these two plates. Again, the capacitance of the capacitor, basically with the help of basic equation, C naught is equal to A epsilon naught divided by D. Here this E naught is equal to electric field without dielectric. First of all, here we are going to give the equation without dielectric, and then we are going to see with dielectric. The potential difference V naught is equal to again E naught D. Therefore, E naught is equal to sigma divided by epsilon naught. Again, this sigma is equal to Q divided by A. Therefore, this Q divided by A epsilon naught. Sigma is the surface charge density on the plate. Up to this, we know that. Okay, this is the without the dielectric. Now, where introduce the dielectric slab. हा जो डायइलेक्ट्रिक स्लॅब नॉन कंडक्टिंग मटेरियलचा इथे आपण इंट्रोड्यूस केलेला आहे. याची जी थिकनेस आहे ती किती आहे? टी इतकी आहे, आणि ती डी पेक्षा कशी आहे? कमी आहे. डी म्हणजे काय आहे? दोन प्लेट मधलं डिस्टन्स. या डिस्टन्स पेक्षा याची थिकनेस कशी आहे? कमी आहे. दिस इज द टी. व्हॉट इज द टी? थिकनेस टी is introduced between the plates of the capacitor. The field E naught, that is the polarizes the dielectric inducing charges minus QP on the left side and positive QP on the right side of the dielectric. See, this is the QP. This is the QP. Because of this positive, here the formation of negative charges. Here, because of this negative, there is the formation of positive, and because of this positive, there is the formation of negative. This is the alternate. Because of this positive, negative. Because of this negative, positive. Because of this positive, there is negative. Okay. And again, this positive charge given to the earth, as shown in diagram. Now see, induced charge setup, that is the EP, inside the dielectric in the opposite direction E naught, and the induced field is given by, therefore this EP is equal to sigma P divided by, what is this? That is the induced charge setup because of this dielectric. Therefore sigma P divided by epsilon naught. Again this sigma P, what is sigma? That is the Q divided by A. Therefore, putting this value here, this QP divided by A epsilon naught, here I have written what is this sigma P, that is the QP divided by A. The net field inside the dielectric that is the reduces, that is this is the original field without the dielectric, and minus because of this dielectric. Therefore, which is equal to E is equal to E naught minus EP. Again, this E naught divided by K. Why this equation? Rearrange this equation. This E naught minus EP, which is equal to, that is the E naught divided by E minus EP, which is equal to K, where this K is constant, and that constant is called as the dielectric constant. And therefore, this E is equal to, if you want the equation for this E, on this E, therefore this E is equal to Q divided by A epsilon naught K, because this equation, this is equal to K. Okay, therefore again the value of Q is equal to A K epsilon naught into E, and therefore the field EP exists over a distance T and E naught over the remaining distance, that is the D minus T. See once again, what is this field EP exists over a distance T. Distance T, that is the only having the thickness of the dielectric. म्हणजे जेवढा तुम्ही डायलेक्ट्रिक तिथे ठेवलेला आहे त्याच्यावरती जे काही फील्ड आहे ते एपी इतकं आहे, आणि ते सोडून म्हणजे डी टोटल आहे, डी मधनं थिकनेस मायनस केली, डी मायनस टी, तेवढं जे काही सरफेस आहे त्याच्यावरती काय आहे फील्ड ई नॉट इतकं फील्ड आहे. And hence the potential difference between the capacitors plate is given E naught having the field over the surface, that is the D minus T, and E because of that dielectric only at the T, that is the having the thickness. And therefore again we have the equation, this E is equal to E naught divided by K, and again this E is equal to V divided by D. This is the basic definitions of this E, which we have learned in this chapter. If you read this chapter thoroughly, then you can understand this all concept, okay? Because each and every concept is depending on your basic concept. Therefore, this V, here we only rearrange the equation for this V. Therefore, V is equal to E into T. And therefore, putting this value in this equation, the value of E is equal to E naught divided by K. Again, this E naught common. Therefore, D minus T plus this T divided by K, that is the E naught K, E naught divided by K. So that here here this concept, that is the K. Therefore, again, what is this E naught? Again, this is nothing but the, that is the Q divided by A epsilon naught. And so that finally we got the equation, that is the potential difference between the capacitor plate. That means when you introduce the dielectric in a given plate like this, and therefore finally we are going to obtain the capacitance when you introduce a dielectric slab between them. Therefore the basic equation, that is the C is equal to Q divided by V. Therefore, which is equal to Q as it is, we obtain the equation for this V. Therefore, putting this equation, this Q divided by A epsilon naught, therefore D minus T plus T divided by K, D minus T plus T divided by K. Therefore, again this Q get cancelled. Therefore, A epsilon naught divided by D minus T plus T divided by K. And see the special cases. If the dielectric fills up the entire space, then what happen? म्हणजे थिकनेस इतकाच काय होणार आहे, डिस्टन्स डी, दॅट मीन्स टी ची व्हॅल्यू कशा इतकी होणार आहे, डी इतकी होणार आहे. त्यामुळे इथे जे आहे डी मायनस टी इथे 0 होणार आहे. ओके, देअरफॉर दिस कॅपॅसिटन्स इज इक्वल टू ए एप्सिलॉन नॉट के डिवाइडेड बाय डी. Why D? Because T is equal to D. D divided by K. K go on the upper side. Therefore, equation becomes A epsilon naught K divided by D. That means when this happens, when the dielectric fields between totally filled, not halfly filled, at that time the situation is like this. If the capacitance is filled with dielectric slab of thickness, if having the thickness, then the equation is that is the T1, T2, then the arrangement like this. T1, T2 up to Tn, then this equation becomes, that is the C is equal to A epsilon naught T1 divided by K1 plus up to n number, that is the Tn plus Tn divided by Kn. In this way, we see the equation when we introduce the dielectric slab in the given plates. Therefore, third one, that is the special case, if the arrangement consists of a capacitor in parallel, then what happens? The C is equal to A epsilon naught divided by D, then A K1, A1, K1 up to AN K1, because this arrangement is in a parallel situation. And so we know the definition, or we have seen the parallel combination. Therefore, C is equal to A epsilon naught divided by Dn in bracket. Again, this K1, here the A common. Therefore, K1, K2 up to Kn. And if the capacitor filled with a conducting slab, that is the K tends to infinity, then this T divided by K is equal to infinity. And so the factor remaining only in our equation, that is the D divided by D minus T, C naught, and therefore C is greater than C naught. And the capacitance thus increases by a factor D minus D divided by, that is D divided by D minus C. In this way, here we see the special cases when we add the dielectric in a given plates. Okay, you have seen this equation once again and revise its one again, because this one is a difficult term, little but difficult to understand. Okay, now the last concept of this chapter, that is the energy stored in a capacitor. That is we are using the formula for energy. A capacitor, what is this capacitor? Up to this we understand this capacitor is nothing but the device which is used to store the energy. That means the charging. Charging a capacitor means transferring electron from one plate of the capacitor to another, and the work done is stored in the form of electrostatic energy in the electric field between the plates, and which can later be recovered by discharging the capacitors. And therefore the capacitor, when charging, then we are charging this capacitor from 0 to high. That means here the capacitance C being charged by DC source. जसं आपण मोबाईल वगैरे चार्जिंग करतो त्याच्यामध्ये हीच अरेंजमेंट वापरलेली असते कॅपॅसिटरची. ओके, this DC source of we hold during the process of charging. What's happened? This Q be the charge on the capacitor. That means the initial position, and V be the potential difference between the plates. Therefore, the C is equal to, this is Q dash divided by V. A small amount of work is done if small charge dq is further transferred between the plates. Therefore, the small work for the carrying the charge Q dash and within the potential difference V, then this dW is equal to V into dq. What is this V? Therefore, this V is equal to Q dash divided by C. Okay, we just rearranging the equation and make the equation here for V. Therefore, Q dash divided by C into dq. If you want full charging, then we are going to take the integration. Here, the total work done transferring the charge, that means from 0 position to we are full charging up to Q position. Okay, therefore the total integration we are going to take 0 to Q. Therefore, this dW is equal to Q dash divided by C into dq. Again, this 1 upon C constant term in integration 0 to Q dash dq. Using the integrations law, therefore this Q dash square divided by 2. And from this upper limit, lower limit. Using this upper limit and lower limit, this 1 upon 2, this 1 upon 2, and C remain constant. Therefore, Q square minus this 0 square. This is not necessary to take. Therefore, finally, here this W is equal to 1/2. That is the Q square divided by C. And the total work is stored as electrical potential energy U of the capacitor. And in this way, this total work done can be expressed in different forms as follows. That is the U is equal to, this is the basic equation we obtain here. That is 1/2 Q square divided by C. Now using the Q is equal to again CV, therefore obtain this equation C square V square, CC get cancelled, therefore 1/2 CV square. Again Q is equal to CV, therefore this 1/2 QV. That means here we are giving this basic equation here, that is the Q is equal to CV, and in this way work done is obtained in different forms as given here. In this way, today we completed this chapter here, that is the electrostatics, and in next lecture we are going to start our next chapter, that is the current electricity. Today we stop here. Okay, students, learn this chapter carefully. If any problems, ask me. Okay, today we stop here.